Hello, everybody. So we are very, very happy to have you in the advanced course. And this is where we get really, really interesting because you're going to be doing the calculations yourselves. So first of all, I will let you know that Angelique is also on the line. And the question panel is for you guys to use. Since there's not that many of us, I'm going to actually unmute you, and then you can remute yourself if you want to. But this allows you to ask questions. There's not that many of you. So does anybody have any problem seeing the screen or anything that needs to be brought up right now? Okay, good. Well, we are going to talk about the most exciting thing first, which is quality assurance. Just to get it out of the way as much as anything else, and because the principles in your QAPP need to be implemented as you start gathering your source-specific data. So again, in this course, you now have the emissions data reported by your adjoining agencies like counties and states, and now you're going to start to look at sources that are not in the National Emissions Inventory Database and for which you have to gather the throughput or the activity data. So I will just keep talking until we get some questions, and that's fine. So again, QC is different for an emissions inventory report. A long time ago, nobody had to write quality assurance project plans for emissions inventories, which I think might be too little of an effort, but writing a full-blown QAPP came as a sort of big shock because for emissions inventories, we're just gathering information. We're not making any measurements at all. But the principles still apply. So the principles apply for documenting your data sources. That's what you're going to have to be super careful with. I think one reason that I was attracted to the quality assurance field is because I'm a total slob. I'm a total slob with even information. And what I do, excuse me, what I do is I put all my sticky notes in a basket and then every few days enter them into my computer and write them into the logbook. And if nothing else, tape them into your logbook. So this is the critical factor for QC for emissions inventories, is that somebody else picking up where you left off or doing another emissions inventory in 3 years needs to know what you did to come up with these numbers and where you got the information. Now, quality assurance is always stepping back and looking at the big picture. So external review by a third party. Now, in some cases, you will have somebody, perhaps somebody from your water quality department, somebody else that is technically knowledgeable and can just read what you've done, your calculations and your report, from a common sense perspective. Now, if you want somebody to actually review your values, you may be super lucky and find somebody like that, but chances are that's going to come down to us. And by us, what I really mean is Angelique. Although I will say that I've reviewed a few emissions inventories, but this is a really, really big job. And QA always involves external review by a third party. So where to start? Well, first of all, before we get into this, I just want to see, which I can't actually, excuse me, I want to back up a little bit and talk about the roadmap to your emissions inventory. So what we're talking about now is adding to your existing project. One thing to keep in mind is that in your report, you should keep separate the data from your reservation that you're gathering the information on now. You should keep that separate in your report from the National Emissions Inventory data that you imported. So documentation is key for that, especially. So the first step is to write a QAPP using our example. And going into the course, so I don't know if you guys have poked around, but everybody should be registered for this course now, and so it appears as a new course in Scholar for you. And if you scroll down, you see resources, and here are some great resources for you, including these PDF documents that are EPA documents, a model QA plan for states, and when you read that, you will be so glad that Angelique and I wrote this one for you because it's crazy detailed, and the Level 2 Quality Assurance Project Plan example. So when you go to these resources folder and open this, you will see a document that looks like this: Quality Assurance Project Plan, your name, Level 2 Emissions Inventory. Now, as you go through this, you'll see text that's highlighted, and you need to be sure to highlight that. Depending on your view, the way your Word is set up with your menus, you may have to look at comments specifically by going to next, next, next. But if you've got it set up the way I have, you'll see the comments over here in the right-hand margin. All of these comments are information for you, and then when you're finished and you've done it, or you say, oh, that comment doesn't apply to me, then you right-click it and delete the comment. So obviously you want to go through this carefully and scroll down, make sure you change any text that's highlighted, and then go through and read these comments and then delete them. So this is the example. It will look very similar to quality assurance project plans that you are familiar with because it has the same general format. And that is, again, here in this resources. Does anybody have any questions about that? Okay, so continuing on with this roadmap, and we will put this in the resources if it isn't already. Not yet. We will put this roadmap. Basically what this says is just these are the steps you're going to do. First, write your QAPP, and if you'd like us to review it, I'm always fantasizing that people don't want me to review their quality assurance project plans, but I will, and you can submit it into the system in Scholar. Then the next step is to list the sources you already know about. So you know what's going on your land. You know how many gas stations there are. You know if there's gravel pits. You know if there's lumber mills. So list the sources you already know. Everybody's got roads, dirt roads, paved roads. List the sources you already know about and tentatively categorize them. It may be that if you've got a bunch of gas stations, you might treat those collectively as a non-point source. Or if you have only one, it might be easier to treat it as a point source. Research online to find information about the sources. So I can't emphasize this enough. I'm always impressed with Angelique's ability to track down information. And you know what she does? She Googles it. She researches what is this, say for example, some sort of facility. I mean, there's all kinds of facilities and we don't know what they are. Just start researching it. A lot of times you may find even specific information about that type of facility. And then if you have any issues with getting information from the people who are operating that facility, it's always a possibility to use default or example information that is probably pretty much the same that you got from somebody else who is willing to share their information. Use TEISS to determine what information is needed as input to make estimates of the source's emission. So let me show you in TEISS when you're looking through and you're saying, okay, now I've got these sources, I need to find out information about them. Research what information is needed by looking at the various menus that are in TEISS, especially the calculators. So you could go to Tools, Emissions Calculators. Now, this is for research only. So emission calculators here will pull up this great wealth of information in a new panel. So sometimes things are hard to find, but if you click the plus box and go through, there's some sources that everybody has. So residential wood stoves, click on that. You say, okay, there's different kinds. There's the pellet stove. There's the catalytic wood stove. There's just an old-fashioned block of iron that I put wood in. How do I manage these different types? Is it important that I go around and ask people door to door what kind of stove you have? Click on this button down in the lower left, and that pulls up an estimator panel. And this panel gives you the information you need for your calculation. So there's two tabs at the top. First is process information. And so we're saying, all right, we want the output in pounds. The stove type, click the drop-down box. These are the different selections of stove type. So let's just say, I don't really know what it is. It's a pre-phase 1, conventional. So that sounds like the oldest kind. And then you say, okay, I would put in my tons of wood here. Is there any other information I need to gather? Well, no, because the next step is calculate. So what you need to know here is what kind of wood stoves. And sometimes that's possible to find out for your area also by looking at census information. So again, if you go, once you're in TEISS, if you go to Tools, Emission Calculators, you'll see all these informational panels, including the calculator, which shows what information you need to gather. So, for example, another source, petroleum industry, which apparently runs our world. You have, and sometimes if you search, things won't come up. I spent a long time searching for gas station in TEISS. It's like, what the heck? Why can't I find gas station? It's because it's called a fuel service station. And these are probably terms that the NEI uses, so it's all consistent. So, okay, a gas station. Click here for the estimator button, and that tells you what information you need. Oh, look at this. There's different kinds of emissions, basically 4 kinds. Tank filling, which I always assume is splash filling, because it sounds like the messiest. Underground tank breathing and emptying, vehicle refueling, and vehicle refueling spillage, which is the one that I always assume. So this information is super, super useful. Okay, going back to the roadmap. So then you have, everybody has to do this thing that sounds so horrible, but once you do it a few times, it isn't that bad. Find out what the information is from the source that you need. So a lot of times they might not know like how many gallons of fuel oil, but I guarantee you there's somebody there that knows how much money they spent on it. So in that case, what Angelique has shown me that we do is, hey, we just find out what was the price of that particular kind of fuel oil, and then assume that that is how much was purchased based upon the records of how much money this facility spent on fuel oil. So we have some example letters, but I found with this, as with a lot of information that you have to get, sometimes it's easier just to call them up and speak to a technical person rather than getting all the management involved. But that's up to you, and we can assist you with that. Then perform QC checks on the activity values, including units obtained. So basically this is a common sense check. Does it make sense that they used, 1,000 gallons of fuel oil for just one little school that only goes up to the 5th grade and has 3 rooms? That kind of check. And usually that is researching against other sites. So other facilities that have similar types of activity. Is this consistent with what they're reporting? Then use the calculators to produce the estimates. And then, again, common sense QA to make sure that the tons emitted or pounds emitted produced by TEISS make sense. then it's really important that you perform QA throughout the project. And the reason for that is I can't tell you how many times I have forgotten something that I was sure I was going to remember. It was like, this is the back of my hand, because I worked on it for a few weeks. But then I put it down, I go work on something else, and this is the case for every single one of you. Then you've got so many different hats to wear that then when you come back and pick up TEISS, you don't remember. And you're like, oh my God, I don't even remember entering that. Fortunately, you kept notes in your logbook. Even if it's just sticky notes taped in there, you can go back in and regenerate your assumptions and your calculations. And then finally, write the draft EI report. Again, the thing to remember is that you want to keep the sources separate. The sources that you're now gathering information and doing the calculations on, and keep that separate from all those sources that were already in the National Emissions Inventory database. For one reason is you don't want to double count them, and then when you go to upload it into NEI, it won't take information that it already has in there. Is TEISS, we got a question from Marlene. Is TEISS going to include above ground tanks? Angelique, do you know the answer to that?
Yeah, I do know the answer. So that particular calculator that Melinda showed you is for the underground storage tanks at a gas station. And TEISS does not have a calculator that's specifically for above-ground storage tanks, but there is an EPA model, and it's called tanks, and you can use that model to estimate emissions from above-ground storage tanks, but TEISS doesn't have that model incorporated into it any longer, but there is the EPA model.
Lucky you, Marlene. Okay, now I showed you the roadmap, and I'm going to go back into our PowerPoint. So, again, write your QAPP using the template. Keep in mind what you're going to do with this emissions inventory report and data. If you think that there's anything that might possibly be controversial, keep notes like your job depends on it. You can never, ever write down too many assumptions. Write down in handwriting, write on a sticky note, write it down, make sure that you have documented everything so that anybody second-guessing your calculations can go back in and say, well, yeah, according to her assumptions, which makes sense because she compared them against all these other gas stations that process similar numbers of cars, and that all that information of that comparison is in there. Yeah, what she did makes sense. So if I don't know of anybody who's writing a level 1 emissions inventory. A lot of time level 1, there's some sort of litigation going on, so I hope not. Level 2 supports strategic decision making, so that could be whether or not you're going to implement some sort of control measure like spraying down dirt roads or something. Level 3, general assessment or research, so that would be tracking changes over time, doing a baseline emissions inventory. And then level 4, we all already did. So data quality objectives. So the idea is that the objective is the objective, right, for this emissions inventory. How good or how close to the truth will your emission calculations be? Keep in mind that this is all estimates. You can't know the exact truth about what is coming out of this facility. All that can be done are these estimates. And that's fine, because nobody, even if you had a stack monitor, you wouldn't monitor every single thing coming out of the stack. You'd only monitor like this one corner of the stack and assume the rest of it is identical. So data quality objectives are set, and you can see in the example plan, they're qualitative. Basically, we will be as accurate as we can be. Now we get into something that you can actually do, which is the quality control. So what does the quality control look like? It looks like documentation. And it's really, really important to allocate at least 10% of the resources for quality assurance activities. Don't wait till the end. I presented last week at the Tribal Emissions, excuse me, at the Tribal Exchange Network conference, and one of the biggest issues that I heard from tribes regarding QA is that their management doesn't understand why it takes so long to do what they do, and a lot of times that's because of the documentation. So a lot of managers, assume like, well, the work is going out and gathering the information, doing the calculations. There's also a big chunk of work that is documenting it. In quality control, you've got to think about things like the transcription of data. So when you found out something from somebody over the phone and you're scribbling it in your notebook, and then you go and enter it into the TEISS calculator, for example, you need to, at some point later, and hopefully another person, that would be awesome, but in most cases it's just ourselves later, check that transcription. And then the next step, when you take this summary tables from TEISS and you export them into the emissions inventory report, sometimes you're typing in values that you calculate in Excel also, and those values have to be double checked. So calculations of the throughput, calculating emissions with the TEISS calculator, just check that the throughput multiplied by the emissions factor equals the emissions, which in most of the case is really, really simple to check. So let's see if I can show you that. So for example, I'm going to go to the input screen, which takes us to linear data entry, and then I'm looking at point locations, and then let's say we're going to go all the way down and look at the actual emissions, and we're looking at the emissions from this rock company that bags their emissions. So they have big stack bags that basically capture most of the stuff coming out of the stack. They do something with mineral products. This particular process looks like it's a conveyor belt. And you can see that the emissions are calculated down here. Now this is already existing information, but if you go in and look at any one of these calculations, you can click Edit, and then you can see what TEISS has done to do these calculations. So you can see what the pollutant code is, you can see the calculation method, EPA speciation profile, etc. These panels have a lot of useful information. Excuse me. So let's go back to the PowerPoint, and they're pretty easy to check, the calculations. The unit conversions need to be correct. That's the hugest thing, is getting the units correct. For some reason, America, this great country, uses units, I think they're actually called British imperial units, like foot and pound, and none of these fancy joules and ergs for America. We use all these units that require a lot of conversion. So verify that the units of your data match what TEISS is asking for. And when you look at the calculator, and this is an example of a calculator. Let me go in and show you where that is in TEISS right now. If you go into TEISS and look at the emissions calculator, and let's just say we're looking at something like plywood manufacturing. That's happened a few times on tribal emissions inventories. And we click Estimator. That opens up this panel, and you can see that in this case, what TEISS is saying is, okay, do you want the outputs? You have your choice of the outputs being in pounds or kilograms. And what do you need to enter is down here, the amount of veneer processed in cubic meters. This could be something else, so you have to be really careful. If you get the amount of veneer processed in, I don't know what other volume units, cubic yards, for example, that might be something, then you need to convert it before you use the TEISS calculator. And just to show you where that calculator is, let's just say we process 1,000 cubic meters of veneer at this facility last year. I say calculate, and then the next tab here opens with the actual results, and you can see the emission factor. For example, for terrene is 4 times 10 to the minus 2, and super easy calculation. Multiply that by the 1,000, which TEISS did, and you get 40 kilograms of whatever this is, 3 terrene. And you can see making plywood puts out a lot of crap in the air. Wow. So that is just show you one more time, tools, emission calculators, find what sort of emission you're interested in here. For example, agricultural tilling. On the very bottom, click estimator, and that brings up this calculator that shows you what the input is you need to have. Tillings per year and total area tilled. So both of those would be very important, obviously. So I'm going to close out of that and go back to our slides. So make sure that your input is what TEISS is asking for. Documentation, consult your logbook. Make sure that your logbook is legible. Somebody else coming in 3 years from now, perhaps now you have the job of tribal chairperson, and they're doing this. You don't want them coming to you and saying, how did you do this calculation? Completeness checks. Look at the list of sources that you're going to be doing as part of your homework and make sure that you've covered them. Are there different types of emissions that could be released? A lot of sources have fugitive emissions, which just basically means emissions sneaking out and can't be controlled. So all the different types of emissions have to be included. Consistency checks. So if you're looking at non-point sources and both the non-point sources are over the same area, make sure you're using the same area. Double counting. Double counting can be done easily, and you just have to be super careful. And then reasonableness. Look for the emissions inventory that your nearby counties produced online. Like I can go online and find all the emissions inventories for Pima County, Maricopa County, and look at their report and their calculations, or at least the final numbers, and make sure that what you are putting together is consistent. Keep a file. What I actually do is I create binders because I have one notebook, and I learned this from Angelique. I have one notebook, and I write everything in there, but then, like if I'm helping multiple tribes, I'll put it in another binder pertaining to that tribe, or else I won't be able to find it in my whole big giant logbook. You are just working with one tribe, so it should be more straightforward. Chances are you're going to have other pieces of paper. Use a checklist. So at the end of the quality assurance project plan, if you go all the way to the very end, there is a checklist. And this checklist says to be completed at least every 2 weeks. What I do personally, because I'm such a mess unless I do this, is take at least a few hours every Friday afternoon and organize all my sticky notes and all the stuff I've done and make sure that, most importantly, I haven't forgotten to respond to one of you, which happens, unfortunately, a lot. And I've documented everything that I should for when I pick this project up again in a few weeks. So this attachment A is at the end of your level 2 QAPP example. You can use this checklist to record who did what when. Basically, that's what you need to record. So who got the data, who did the calculations, who checked for reasonableness. Don't make the mistake of doing all this stuff and not documenting it, because essentially you don't get credit for it if you don't document it. I mean, not for me and Angelique, but for somebody else who picks up your emissions inventory and needs to update it or figure out how you did the calculations. So make sure when you check against another, for example, a county emissions inventory report, document that you did that. I really also like sending emails to myself. If you send an email to yourself with the subject line showing information about what your email is about, then at least you've got it stored in your email and on the server in case you have a fire or a flood and lose your notebook. So data tracking, the full file names and paths of your computer files. So a lot of times, like our documents folder isn't really the documents folder that we think it is. So make sure that you look at the full path when you're recording where your files are. Reality checks. Does this make sense? I guarantee you it's going to blow your mind the first few calculations you do, because the emissions are a lot. And you're going to think like, what? Pounds of carbon monoxide? How can that even be? So go online and look, and you'll realize, wow, no wonder we need the EPA, because these sources emit a lot. Never use this reality check as the sole criterion of quality. Really make sure you look for similar sources. And it's also the emissions inventory system gateway is also available for you to look and research similar sources. Peer review. So this is where if you have somebody that you work with who is trained enough, and they don't have to be a lot trained, just technically savvy. They could be a water quality monitoring person, for example, can review your report, review your assumptions, and make sure you document that. You go down the hallway and you stick your head in and you say, does this make sense that this gas station would emit blah, blah, blah? And they say, yeah, things are really surprising. Let's research this other gas station. And you do that, and you're like, wow, yeah, go write that down. Send an email to yourself. Replication of calculations. So the most reliable way to detect computational errors is, of course, doing them again. And for states and counties that do emissions inventories, they do this 100% of the time. In fact, what they do, and I'm not sure all of them do, but two that I've researched, they have another person go in and data enter all the same numbers. And then if they're the same, they know that that was correctly transcribed. In general, a rule of thumb for QA is that 10% of the checks should be, 10% of the calculations should be checked. And obviously, if you start finding a lot of mistakes, then you probably should check more. Computerized checks, those can be set up. Double entry system is something that Maricopa County does. TEISS doesn't have a system where you could go in and type it in again, and then they would check to make sure that they're the same. But just so you know, that's what counties and states do. TEISS still needs a human touch. Like any computer program, it just does what you tell it to. And if you tell it to do the wrong things, then it's going to produce the wrong things. So research what calculations you're doing. Make sure you read the EPA information page. So looking at TEISS and going back to Tools, Emissions Calculator, and then now let's just look up fertilizer application. That's something that a lot of people have, pretty much everybody probably. Read this information from the Commercial Fertilizers Database compiled by Tennessee Valley Authority. Read this sheet. It gives you the SEC codes. It gives you where they got this information. And this actually might not be the best. This actually doesn't have an EPA link. Usually there's an EPA link. Let's look for mine. A lot of people have mine. So make sure you read this. Well, why aren't these links in here? This is weird. Mining and querying README file is not a link. Let me find one that is. Okay. Mineral Productions Industry. asphalt roofing. Here we go. So if you've got roofs that are going on all the time, for example, and you need to read about it because they sure stink, so they're emitting something, read this page as well as this link that takes you to EPA's Technology Transfer Network, AP42, and at the very least for all your sources, go into the TEISS emissions calculator, read about the source on that page, click on the link, and research what it has here. It'll take you 45 minutes to read, and then you'll avoid making mistakes later when you realize, oh, I should have used hot asphalt or whatever the difference is. So again, that is from tools, emissions calculators, pick your thing, and then find if there's an EPA link here and read it. Here's one under agricultural tilling. They have a link. Okay, back to the PowerPoint. So that is the page that you should definitely read. Okay, so this screen shows you what I've been showing you a few times. Tools, emissions calculators, and then here's a link on that page, and it can be eye-opening what you learn. So the reason is because, for example, for gas. So we've got these 4 types of ways that the gas and the volatile organic compounds from the gas can get out. There's the tank filling, tank breathing, vehicle refueling, and then spillage when you refuel, and then there's another type down there also. So you won't know what these mean unless you've done the research. So, for example, you've got 4 different operations in any gas station. Filling the tank, and then the tank, for some reason, has to breathe. I guess as you know, the temperature of the soil changes, the size of the tank changes a little bit, and that's probably built into the way they build these tanks so that when the temperature goes up, there isn't an explosion of the gas in the tank. And then vehicle refueling displacement losses, and then vehicle refueling spillage. So you won't know that each operation should be included as a different process in TEISS unless you read about it. If you're using an EPA model to calculate on-road emissions, make sure that the vehicle refueling emissions are not double counted. A few of you are, and we can help you with that. Typical errors include missing facilities. So if you have a facility and you can't get any information about it at all and you don't want to include it, say why, so that people don't just think that you skipped it. Duplicate facilities, improper facility excuse me, locations, missing operating or technical data. So like that could pertain to the season, right? So like a lot of activities on tribal land are recreational, right? And a lot of those recreational activities only occur certain times of the year. Snowmobiles in the winter, using your boats, maybe depending on where you are, in the summer. So that kind of information is easy to make a mistake on. Erroneous technical data, double counting, errors in the calculations, and then data coding errors, including using like the wrong code. The biggest problem is letting it slide. So again, take a few hours a week, and maybe you'll turn into a whiz, and it'll only take you 20 minutes a week, or you'll figure out a way to incorporate it as you go on. But I highly recommend just sitting back at some point, and that's why I do it Friday afternoons because I'm already so tired, and think about, like, what am I missing here? What do I need to organize and document? You will be under pressure to get it done. I mean, I always feel under pressure to get things done for you guys. So that's why I try really hard to document things, because if we present like a default or something like that, I need to tell you where it came from. The documentation is important because basically you need to ensure that somebody else could come up with the same numbers. That is the hallmark, if you think about it, of scientific credibility. The scientific method basically comes down to doing it again with the same input and coming up with the same answer. That's repeatability, and that's science. And that's what you want to have with all the documentation for your emissions inventory, especially because in many cases this is the foundation for future inventories. So somebody else coming along in 3 years is going to pick up your calculations and probably do them the same way. So you want to make sure that you document it in case like something's changed, like now they use a different kind of boiler or a different kind of gas or something like that. And that person in the future, or you, needs to know what kind of gas or boiler you assumed. So QA is sitting back. For example, ITEP can provide assistance. I will say that there is a law that says that the federal government cannot do something that a contractor could do. So I encourage you to kind of downplay us. I mean, we're not a contractor, but we do get federal funding. So the way our grant works is that we provide assistance and training. So we can't actually like do the work and write you a nice audit report, which would be a lot of fun. But we will check your numbers for you. And I guarantee you, Angelique will find mistakes. It's amazing. So 10%, and that's, you know, something you could tell your supervisor, hey, it's a rule, 10% of my time is QA. I need to do this. And the QA person checks a fraction of data entry calculations, documentation, etc. So just a few sources they can check. And if you're doing this check on Friday afternoons, that's why it's nice to do it at a set-aside time so your brain can kind of like stop and then think big picture. So there's Obama. The Quality Assurance Project Plan, basically the important thing about it are those signatures, because I hope that anybody who signs something realizes that they're committing to this. So that's why it's really good that we have that signature page signed by your supervisor and anybody else involved saying, okay, as long as you do what you say you're going to do in this QAPP, you're fine. And I'm not going to come in and say, oh, why didn't you do that? Or why did you spend so much time doing that? No, I agree to it, and here's my signature. And obviously it's required by EPA. I was sort of hoping that maybe at some point with our new administration, EPA might lighten up on Quality Assurance Project Plan. But I think that's probably too much to hope for. But that could be something that the federal government could lighten up on, I think, is QAPP. Basically, the foundation of who is going to do what, when, is documented. Goals and objectives, so it's really good. You know your supervisor signed this, so when they say, oh, I thought you were going to do blah, 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 you can say, no, you signed this. This is the output in my Quality Assurance Project Plan. And it should serve as a roadmap of actually the requirements for you conducting the emissions inventory. It doesn't have to, and it shouldn't have like the procedures, but a Quality Assurance Project Plan has to have the requirements that must be met by your data gathering, your documentation, your double checking, your calculations. And long-term guidance. They're very useful for the next person who comes along. And they make writing the EI report easier, which is true. So let me show you this now, this wizard for the emissions inventory preparation plan. Actually, we're running a little low on time. Let me just show you where it is, though, real quick. So this, in case you guys haven't found this, the inventory preparation plan opens up a really nice wizard, and this was done a long time ago before EPA required Quality Assurance Project Plans for emissions inventories. And what they said is, oh, that's okay. you just should write an inventory preparation plan. And it's sad, if we had 30 cents to pay our contractor, what would be awesome is if we could go through and change this format to generate a QAPP. But that's what this refers to, this inventory preparation plan. And I do think that some people use this. It's a great place to document what you're doing, but it doesn't produce a nice report that is required. So that's what that is. This is just the screen from the inventory preparation plan that shows you these are all the same things as it's going to be in a quality assurance project plan, but if it's not in that format that EPA expects, they're going to be sad because they want their life to be as easy as possible, and they need to check off that you did this section, that section, this section, and the inventory preparation plan is not organized in that way that makes it easy for EPA, and we want their jobs to be easy. Oh, this is a nice picture of some people at Navajo Nation when we were doing some work there for their air monitoring. So the use, what are you going to do with this emissions inventory? Well, it's very important to see what's being emitted now for planning for the future. It's a fundamental cornerstone of what you need to develop a tribal permitting program. Obviously, you're going to learn about your sources, and you need to know what they're emitting now in order for you to move forward and develop a tribal implementation plan. And it also puts you on the table, so to speak. So when you write an emissions inventory, including the sources on your land, and you then provide it to us, and we work with you into uploading it into the National Emissions Inventory database online, that puts your land and your data and your sources on the table for all the people in your regional air quality planning group. So like the western states have RAP, and there are similar organizations in different parts of the country. And that means that basically now that your data is in an NEI, they need to take that into account. So it's really good of making your program, it's good for making your program visible. So again, start with a QAPP and then list the sources on your land that you're going to be gathering information from. And in terms of your emissions inventory report, remember, you need to keep the data separate. So the data from the off-reservation sources will be in a separate section in your emissions inventory report, obviously because those have already been reported to the NEI, and also to keep things clear for the readers of your report. So this is an example of what you need to do now, along with writing your quality assurance project plan. This is from Chris Ray. Angelique and I worked with him a few years ago now on modifying TEISS, and he was really helpful to us when we used to teach this as a classroom course. But now we've realized we can't because there's so much work to do. We can't possibly get this done in a week. So this is from his land, and these are sources that he had to find information about. So Pine, that was just the name of this facility, and what they do is they cut wood. Then there's a plywood and veneer facility, and that's what they do. And in this case, if they've got a Title V permit, that information is available online, and that will be very eye-opening. Then a pellet stove pellet manufacturing place, and then asphalt, and then, of course, the ever-present gravel places where they make concrete or they just dig it out. So this is the kind of list that you want to start to assemble for your sources. Excuse me. And this is an example of the reporting that TEISS can help you with in terms of printing out these screens. Just in the interest of time, I'm going to keep going. I encourage you to look at the videos online and the notes document for this session, which has more detailed information. So keep in mind that DQOs are general statements. They're not, like for DQOs for air monitoring, for example, the DQO is we want to be sure at a 95% confidence level that when we calculate attainment for this site, we are making a mistake only 5% of the time. That's a DQO for a numerical value that you can calculate based on the bias and precision of what it is you're monitoring. Now, for these, we are going to have general statements. We're just going to say, like, well, we're going to be as accurate as possible. But you still have to make those statements. And then what matters are the data quality indicators. So the data quality indicators. So for like air monitoring, for example, data quality indicators are the bias and precision because that's all you can measure. You can't say that I'm making a mistake less than 5% of the time when I calculate attainment and know that you're right for sure or measure that. All you can do is measure your bias and precision. For emissions inventories, all you can do is say goals for things like completeness. I will inventory for sure 100% of all the Title V sources within my area, and those will be included in my emissions inventory. That is one of the data quality indicators that you can actually do for an emissions inventory. So this is just an example. So the data quality objective for accuracy is we're going to download all the data for the whole source, and then in this case, actually, we have to use Excel, and that's sort of the bad news that we'll talk about in subsequent modules. But it's just a general statement. However, the data quality indicator is what you're actually going to do. So we're going to track the sources in TEISS's QA/QC notes field. So we have 6 minutes left. I'm just going to show you that real quick because it's so cool. So if you go to data input and you look at, for example, a point location, and you go all the way down to the actual emissions here, and we look at these calculations that were in here. If you go to edit, that pulls up all this information that's in TEISS. And you can see there's really cool things like a change log. So anytime you go in and change the numbers or add information, let's see if this change log shows anything. No, only one thing was added. But if you go in and look at another source that I've fooled around with, which there will be a lot of them in your project, if you go to input, which brings up linear data entry, and we're going to be talking about this more in subsequent units. You go down to actual emissions and edit, you could see all the information, and it's actually, this is a really, really useful screen because you can do research from the screen also. But I'm going to say cancel for now, and just tell you that there are areas in TEISS where you can look and see what the value was before and what it is now if you changed it, which is excellent. The QA/QC section of your quality assurance project plan, how are data collected? Well, I'm going to research on the internet, I'm going to call people, and if necessary, I'm going to go knock on their door, and I'm going to document everything. I'm going to document it in my notebook, and I'm going to document it in TEISS, and I'm going to document it in my email. How are data checked? Well, every Friday afternoon at 2 o'clock, I sit down and I double check everything I did. Where are the data stored? It's on our network server, and this is the path link, and I also put it on a USB drive. So nothing fancy. What makes sense that you can do? The worst kind of quality assurance project plan is one where nobody knows what it says, and then clearly nobody does any of those things. And quite a few times, those QAPPs look really great, and they may be even approved by EPA. But it doesn't make any sense. Then it's just a total waste of time. So this should actually say what you're going to do. So one sentence is all that's necessary. How are you going to store your data? You're going to store it in TEISS. you're going to do work on a piece of paper that you will keep. If you do any work in spreadsheets, you will back those up. Then you're going to say, what am I going to do? What is the product of this effort? Well, I'm going to have a completed TEISS project. And by TEISS project, what we mean is this. This is the Hameb Potolel Tribe project. And all the information is in here, but you need to make sure that you back it up. So the final product is going to be a complete TEISS project and your paper report, and probably some presentations that are going to summarize the report, your results. So this is my motto in life, although I think it should be a better motto, really. But just get it over with. Do stuff now. Just revise your QAPP if you have already started it, and let us kind of bug you. If you work alongside us, it just keeps your momentum going. Although, as we've told you for sure, we work with you on your schedule.